Hi, and welcome to another very exciting tutorial packed with tons of stuff. In this tutorial, you're going to use machine learning and computer vision to create a cool remote control app that lets you play and pause a video by opening and closing your hand. To build that, we'll first use more than 200 images of hands to create an image classifier that is tailored to our needs. We will then create an app with a simple video player based on AVFoundation that can also stream media to an Apple TV using Airplay. To process the live camera information from our iPhone, we're going to use the Vision framework together with our machine learning model to detect if we opened our hand to play the video or made a fist to pause it. This app is potentially the perfect companion for a WWDC or Super Bowl party if you plan to serve chicken wings or other finger food that could make your Apple TV remote or iPhone dirty, because you won't have to touch either of them to control playback. So let's start with step 1, creating a machine learning model for our purpose. And as you can see, I have a folder here for the machine learning model data. And what I have are a training folder and a test folder. And I took over 200 photos of fists, of nothing, so just plain backgrounds of the ceiling, actually, because you put the iPhone somewhere and then it's going to look at the ceiling. So this makes sense to just call that none, for example, to have this option to detect also when there is nothing at all. And I have open hands with different backgrounds and different situations. These photos are all taken in my office environment, so this is maybe not universally usable for every environment, so be sure to take enough photos here. And then very important for testing and training is that you get about an 80-20 ratio, so 80% of the images will be used for the training, and this is everything that I put in the training folder, and 20% for testing. And as soon as you have these images, what we can do is create our own machine learning model using CreateML. So I'm going to bring up Xcode right here and create a new playground for macOS. And we can just use a blank playground right here. Let's just call that maybe hand classifier, and let's hit create. And with that, we have just this nice little playground, which I'm going to resize a little bit. And we don't have to import Cocoa here, but create ML UI. And it's very simple. We just have to create a builder object using ML image classifier builder, initialize that, and then we take this builder and then we just show our inline view. That's all there is to it. We can directly run this. Make sure to open the assistant editor for this to work. And then we have our folder here. So be sure to also separate your images into a training and a test folder. And now what I can do is just drag and drop my training folder into this drop area right here. And then CoreML or CreateML is going to do the rest. You can see we're running through all of these images that I took from hands and skies and ceilings. And that's actually taking just as long as that. And now we have completed training, and we can now perform a test to see how well our model performs. So I'm just dragging my test folder into the CreateML UI. And as soon as we have completed this test, you can see that we have an accuracy of about 58%, which is good, could be better, but for our purposes, this is going to be enough. And as you can see, we have built an image classifier, so we have to name that somehow, and I'm just going to press the arrow here. We can give this a description. We can enter classify open hands, fists, and nothing. I'm just going to go with that text. Doesn't really matter. Provide a license if you want, a version, author, and I'm just going to give this a name. Let's also say hand classifier. Saving that. Choose my my models folder. Open that and hit save. And with that, we have a CoreML model that we can use for our purpose of detecting open hands, fists, and also to distinguish if we're seeing nothing at the moment. Now, in this next step, we're going to do two things. First of all, I'm going to show you the project that I'm working with. This is nothing fancy. And we're also going to set up some of the basics. So we're going to add a video player right here that can also use Airplay to stream the media, for example, to Apple TV. And this is going to be what we're doing right now. After that, we're going to focus on vision and our CoreML model. But first things first. So in this project, I have just a single view controller with a image view that is going to display two different images, our open hand image and our fist image. So this is all that is going to be displayed in this image view. Then we are having a player view. I just gave that a background color so that we can distinguish it from the rest of our view, which is just totally black. And here I left out some space because this is where I'm going to add my Airplay button. And all of that is just created using auto resizing mask, so I didn't use auto layout here or auto layout constraints at all. And this player view here is actually a custom class that we're going to create in a second. So I actually already created a file, but we're going to fill it with some code in a second. And then we have our view controller, which just has a bare bones structure. I create an outlet for our player view, for the image view, some structure comments to structure the properties we're going to create later for the camera, for vision. And I've created some of these setup functions so that we just have to fill in the blanks here. And they're all called in view.load. So that we can set up everything nicely. But now we're going to focus on our player view. As I said, we have this UI view here that has the custom class player view. And just not to forget, I have this extension here for the view controller. We are going to talk about that later as soon as we focus on vision. And we're going to start now with the player view. And here is just a slight hint from the future because I forgot to mention these few things. As for actually calling URLs that do not have an HTTPS connection, so when they're not secure, what you have to do in your info plist is to add app transport security settings and allow, for example, arbitrary loads. So just set this to yes and add the specific keys and values. This is one thing that you might need to do depending on what URL you're calling. And what I've also added is a privacy camera usage description key just to tell our users that we're using the camera for remote control. If you forget that, you're going to be remembered and you're getting an error message in the console. But what you definitely need to do in your project settings in the capabilities tab is to actually turn on the background modes and activate audio, Airplay, and picture-in-picture mode so that you can actually use Airplay. So that's it. Now back to the past. And we're going to start now with the player view, which is a very simple class. I just imported AVFoundation here because this is what we're going to use for playing our media. And I'm going to have a player, which is a so-called AV player. And I'm also going to have a player layer, which we're going to add to our views layer hierarchy. And this is going to be an AV player layer. And then what we are going to create here is just a simple function. I called a set player URL. It's going to receive a URL. It's going to return nothing. But what we're going to do is we're going to take our player and we will simply initialize that with our URL. So this is very basic, and you could do this a lot better if you wanted to choose between different sources, different live streams. You could also use a player item instead of a URL here to initialize that, so that you could choose your own videos from your photo library or whatever. So you can be totally creative here. I just want to show you the basics of creating a very simple player that can actually be used together with Airplay. So we're going to take this player and we're going to allow external playback, which is great because we're going to use that together with Airplay. And then we also have our player layer that needs to be initialized with our player so that we can also see something. So I'm going to use the AV player layer and initialize that with our player that we already have. And then there's also something like the content mode of a view that we can set. So using the player layer and the video gravity. And as you can see, I can set this to resize aspect fill. So this is very similar to a content mode. And then since we have a subclass here of UI view for our player view, all we need to do is actually use self.layer, because we are in player view and we are a UI view, so we can access our layer, and then we can just use our add sublayer function to add our player layer. And with that, we actually could see something, but I'm just going to resize my player layers frame to our views bound so that we really fill the whole frame or the whole UI view with our video in that case. And to actually display something, we need to have kind of a video source. And I just have a very simple demo video here. You already saw that in the beginning of this video. So I have just switched to my viewcontroller.swift file, and we are actually setting our player up in view.load. We're calling the setup player function. And in this function, what I like to do is using my player view. This is already an outlet that I've connected with my storyboard object, with my player view. And I'm taking this player view and using the function set player URL. I'm going to create a new URL with a string, and this is the string that I'm going to use. Force unwrap this because this definitely works, and this is our sample video for Big Buck Bunny. And of course you could use a live stream URL here or whatever you like. And as I said, if you do not choose to actually use the URL but a player item, you could also initialize it with a player item and use a video from your iPhone whatsoever. And to test this, we will just use our player, manually press the play button, so to speak. So player view, we access the player and just hit the play command. And then we run this in the simulator and have a look at our player view. And as you can see, it definitely runs in our player view. So everything fine here. And we're going to go next for the Airplay function, which is actually really simple. All we need to do now is create a so-called AV route picker view. Therefore, I already did create the setup Airplay function, so let's just use it. It's called in view.load, and what we're doing, I'm just going to call that Airplay, this little object here, the AV route picker view, and I'm going to initialize that with a frame. So let's use CGRect here. The X coordinate is actually it doesn't matter because we're going to center it in a second. Let me set this to 40 for Y. Let's give it a width and height of 80. Well, that's actually it. And then we can use our Airplay button here, center it in X direction using self view, center and the X coordinates so that it's nicely centered in our view controller. And I don't want this button to be blue, so I'm going to give it a tint color. So let's set the tint color to UI color white. And then we're using self view and add our Airplay button as a subview. And if I run this now on my iPhone, what I can do using the Reflector app on my Mac is to actually use my Mac as an Apple TV and just use the Airplay function so that I can switch between iPhone, and I'm now going to switch back to the Mac, and we're going to see the video playing right here. So the Airplay feature definitely works, and with that we have two core functionalities. We have our player that runs a video, and we have Airplay to actually stream our media to an Apple TV. Now, the next part is going to focus on actually realizing our core features, namely the detection of hand gestures using the camera, and then performing or running these images through our machine learning model using vision to actually distinguish between a fist and an open hand. Now, in this third part, we're going to have an in-depth look into vision, because this is what we're going to need to actually use our machine learning model. And using vision is kind of a three-step process. We're going to begin with a request. This could be the detection of a face rectangle. This could be the usage of a Core ML model. This could be the detection of rectangles, whatever you actually need. The first thing we have to do is actually creating such a request and specify what we want to do. The next step is going to be to create a request handler that is going to fill vision with all the information it needs to actually perform the request. So this could be, in our case, a vision image request handler, and you can initialize that with in different ways. We're going to use a CV pixel buffer because we're directly using the camera images we get from the front-facing camera. So this is also something that we're going to set up. And the third step are the observations that you need to handle. So using a handle classification function, not you shouldn't confuse that with the request handler. The handle classification object, or the handle classification function, much more, that we're going to write, is going to receive the request and an error object. And in this function, we actually want to look for or look through the vision observations and get all the info we need, like the probability of the detection and also the identifier that we're getting back from vision, and with that, in our case, from our Core ML model. So this is the three-step process that we're going to perform right now. We're creating a request. We will create the request handler, filling in our video images from the front-facing camera, and then handle these observations. We're going to do this in one step now, which means that we're also going to set up the camera properties right now in our view controller. And for that, we're going to need a capture session, which is a so-called AV capture session. And this is actually coming from the AVFoundation framework. We are also importing the Vision framework, of course. And for the usage of Airplay, what we already did, we imported AVKit. So just that you know what we're importing here. So here using Pascal case, of course, a capture session. And we're also going to need a capture device, which is our front-facing camera in that case, so capture device. And we also need to specify there's also actually a variable. We're also going to need the device position, going to initialize that with AV capture device and position, and set this to front right now. So these are the things, the objects that we need, or the properties that we need for our camera. And then what we are also going to need is a requests array that we're going to initialize with vision requests. This is something that we need later, and we could perform multiple vision requests at once, but we just need this array for our one request that we're going to make. So in view.load, what we have is actually the function for setup vision. And what we will also need is a third function that I'm going to write in another class here, or in the extension of our view controller class later, but we're going to add that to view will appear. This is going to be for the preparation of the camera, but now first of all we're going to concentrate on vision. So the first thing that we need to do now is to use a model, a classification model, or to get an object for that. We already created that model, which I saved to a models folder. It's called hand classifier, and I can now drag and drop this classifier to my project, hit finish right here. And as you can see, we get a lot of information. We get the description that we gave it earlier, and we also know that we need to input images in a resolution or in a size of 299 by 299 pixels. And we will get back a class label. This is the most likely image category, so this would be for our case fist, open, and none. And we get the probability. And working with these models is possible without, or working with an image classifier is possible without vision. But here you're going to see that this is a lot easier using vision than if you didn't. So let's just continue. We want to set up vision now. So we called set up vision in view.load, and now we're creating a vision model object. This could fail, so I'm using guard let here, and I try to use now a vision core ML model, and I initialize that with my hand classifier, initialize that here, and its model property. And this really has to work. If it does not, then we need to throw, for example, a fatal error and tell us ourselves we can't really load a vision ML model. And if this works and we actually have a model, then we can continue and we can create our classification request. And this is going to be a vision core ML request because we have a model and we want vision to detect things in this model. And we're going to initialize that with the model itself and a completion handler, and this completion handler is actually used for our observations. This is not the request handler. So we are now creating a request, and we have to specify a handler that we will use to actually get the observations. So this is what we're going to do right now. So we have our vision model, and I'm going to fill in right here. And for the completion handler, we need to maybe define a new function, which I'm going to call handle classification. And what we have to add here as parameters is, first of all, the request, the vision request, and an optional error parameter. We don't have to return anything here. We don't have to fill in everything here. Can keep that empty for now, but we need to specify it right here as our completion handler. So this is going to be self and our handle classification function. No need to specify the parameters here. And now we can make some adjustments right here. So I'm going to use my classification request, and I figured out that if I crop and scale my image, it's going to work a little bit better, and I've decided to use center crop here. And that's actually all the adjustments that we're going to make. And then we have our requests array, and as the only element for this array, I'm going to add my classification request. As I said, you could add multiple requests in this array and perform all of these requests at once or in a sequence if you need it. So this is now all we need for the request, and later we're going to deal with the handle classification. Now we actually need to think about this middle part here, about the request handler that we use to actually perform our request on images. And what we need to do here, we already created our camera properties, but what we still don't have is a way to actually get the images from the camera and also work with them. Therefore, I've created an extension for our view controller, so simply an extension, and also adopted the AV Capture Video Data Output Sample Buffer Delegate. So it is a long name, but very useful in our case. It's coming from AVFoundation, and we're going to need vision in this context. So what we're going to do first is prepare our camera. Very simple, actually. So let's just write a function, prepare camera. And we're also going to call this function so that we do not forget that InView will appear in our main view controller file. So let's call prepare camera right there, prepare, and this works. All right. And now that we have this function, what we need to do is first of all check what devices are actually available, or get a list of available devices. Therefore, I'm using AV Capture Device and use a discovery session for an array of device types. So what I'm specifying here is, in our case, just the built-in wide angle camera. We don't need the true depth camera or anything like that. And we're interested in video. We're interested in front devices. And by using the devices property, we're getting an array of all available devices. And we already have a capture device object created in our main view controller file. And here I'm simply going to use the available devices list and choose the first element, because in the front of our iPhone or iPad, we just can use the standard camera without depth information and just get this first element. And now what we also need to do is actually begin a session for our video capture. Therefore, let's create another function, call this begin session, and I'm going to call that in prepare camera. And what we need to do here is specify the input, but also configure our session, for example, with the video resolution, but also tell our data output what kind of video settings it's supposed to use and how we're working with the frames. The function that you see below at the moment, which is called Exif Orientation from device orientation, I took this from Apple sample code that dealt with this problem, or with this request of the vision framework, because we need to specify Exif information, or we need to pass that along, and this is just a function copied from Apple sample code. So in begin session, what we want to do is create a capture device input. And what we have to do in order for this to work is use AV Capture Device input and initialize that with the capture device that we have already created. Since this can fail, we should add a try statement in front or a try keyword here, and put this in a do try catch block, and then we catch a problem. Let's just print here, print could not create video device input, and just return right there. So with that, we have a capture device input, and this provides data or media information from our device to our session, which also means that we need to use our capture session and add this as an input. So capture device input. And now that we have this input, we can also configure our session. So right below, we're using our session, and we want to begin configuration. And we also have to commit these configurations later, but first of all, we begin the configuration. And I'm now using my capture session. I'm using a session preset here, and I set this to VGA 640 by 480 because this is completely sufficient also for the resolution of our images. we just have 300 by 300 pixels, so this resolution is completely sufficient for our purpose. And now we need to work or create an output that we're actually going to use for vision. So let's create a data output object and initialize it with AVCapture, AVCapture video data output. And I'm using this video data output now and access the video settings. And here we have to actually specify a dictionary, because we need to specify the pixel format type key. So I just copied that and pasted it right here to not make a mistake. So we have this key for CV pixel buffer, the pixel format type key, as a string, and as its value, we want to specify this format type. This just specifies how the images are going to be received by vision, and I just figured out that this is going to work best for our purposes using these video settings. So with these video settings ready, we can also specify that for our data output to use always discard late video frames. It's going to make this a little bit faster. And now we need to check if our capture session can actually add output, so and using our data output. And if this works, if we can do that, then we can add the output specifications to our capture session. And this means now that we have configured actually almost everything that we needed, but the session is definitely ready, so we can use our capture session and commit our configuration. And now to actually receive the data from our camera, we're going to use the AVCapture video data output sample buffer delegate. And it's a delegate function, of course. And therefore we have the capture output function that comes with this delegate. And here we are going to use the sample buffer and pass that, or get a pixel buffer from the sample buffer. This is going to include all the image information and that we are going to pass along to vision. But this also means that we somehow have to connect our data output with the sample buffer delegate, which means we're calling set sample buffer delegate. We're setting this to self, and this also needs a dispatch queue. So we're defining a queue object here, queue, and initialize a dispatch queue right here, just with a label, which is going to be the capture queue, and then we can pass that along to our data output. So just passing along queue right here. And now we can actually use our capture session and say start running, which means that now we are actually getting the video information, and we can use that in our delegate function capture output. Actually, not did drop. Capture output did output, not did drop. And we have our sample buffer here, which actually contains the image information. We're going to use a Garrett let statement here to convert our sample buffer to a pixel buffer. I'll actually get the image buffer using cm sample buffer get image buffer from our sample buffer that we have as a parameter here. And if this does not work, then we'll simply return because we cannot continue, but we have now a pixel buffer that we can pass along to vision. And as I said, vision also requires us to pass along orientation information, and therefore I'm going to create an Exif Orientation object using self and Exif Orientation from device orientation. And with that information ready, I can create now my image request handler, initialize that with vision image request handler, and pass along a pixel buffer, an orientation, and options. So first of all, the CV pixel buffer that we're going to pass along. Pixel buffer orientation is the Exif orientation, and we actually do not need to specify any further options here, so just passing along an empty dictionary. And this is now actually the center of our three-step process. We have created a request handler, we have the image information here, we have the orientation information, and now all we need to do is actually perform our request using this request handler. Therefore, again, something that could go wrong, using a do try catch block here, using my image request handler, and now we're going to perform self.requests. So now we're using this handler to perform the request we specified in our setup vision function, the classification request using our core ML model. And if this goes wrong, we will simply print the error that occurred right here. So now I said this is a three-step process. We have step one, the request. We have the request handler. Now we need to focus on the observations. And if we have a look at our view controller, we specified already a completion handler function, the handle classification, where we are going to deal with the classifications that we receive from our vision framework. So in this function, we'll first of all create a guard-let statement for the observations to check if we have observations that we can work with. They will be in our request object and the results. If this does not work, we'll simply print that we have no results here and also return. All right, so if this works, then we have an observations object, and these observations contain a lot of information that we do not really need. So we are going to create a classifications object. And what we try to do here is, first of all, use our observations and use compact map here to just transform them into objects that we actually can work with. So just converting all of them to VN classification observation objects. And all of the classification observation objects do now contain a confidence. So this is the probability. And just if we have a look at our model, we have the probability and we have our category. Or our class label. And using Vision, you always have the same interface that you can work with. So we can now just, for example, use the filter function and then check if each of our elements here has a confidence of more than 50%. So with a probability of more than 50%, we are correct, or at least the model thinks that the classification, for example, is an open hand or a fist. And this is something that we can play around with to see what works better and if we want to change that threshold a little bit. But 50% actually worked in my preparations very well. And then we will also map all of that, take all of the objects and just get their identifier. So just taking them and access their identifier so that we actually have an array of identifiers that we can work with. And then we can actually also print these classifications and already run this now, definitely on a real device. You can't actually run this in the simulator because you need a camera, but if everything works, then we should be able to see some cool outputs now. As you can see, at the moment, we get none. And here we get our video from earlier. But as you can see, we get none. I'm going to hold my fist now over the phone, and this works. Opening my hand right now, and we have open, fist, open, fist, open. And now there's something interesting happening. If I move my hand in front of the camera, I'm just ending my application right now, then you will see that in the time when I move my open hand outside of the camera area, then you see that my hand is still open, and then it detects fist 2 times before it moves to none. Which means that if we started our video, detecting a fist means that we actually pause our video again. And there should be kind of a buffer or a threshold of commands that are ignored before we actually send a command to our video, so actually playing or pausing it. And this is something that we're now going to do in our last step and also updating the UI accordingly. So let's tackle these last few problems and have a look at how we can work with our classifications. If we scroll up all the way to the top of our class definition, outside of our class definition, I'm going to create a new enumeration for our remote commands. And it's going to be a string enumeration. We could also put that in a more suitable file, but for our purposes, this will do. And we're going to have 3 cases. We're going to have none, which is when no hand, no open hand, no fist is detected. We're going to have open, and we're going to have fist. And I'm going to give this open a raw value of open, and I'm going to give this fist a raw value of fist, because as you remember, we have those 2 images here, which are named fist and open. And by using this, I just have a very simple way to later use them. But let's now resolve the problem of potentially wrong commands or potentially wrongly detected gestures. So when we're having a look at our output from earlier, and we're looking at kind of this area, then you remember that we were actually having an open hand and moving it out of the camera area. And while we did that, we detected 2 times a fist, which would mean that we're actually pausing our video, but we actually don't want to pause the video. And a good way to resolve this problem is to actually include a buffer of maybe 3 or 4 elements to be really sure that we detect the command the user intends. So to realize this feature, or to create this feature, let's add a new property right below our vision requests array. And here I'm just defining now my buffer size that we just talked about. I'm setting this to 3, kind of works pretty good. We could also set this to 4, but this adds kind of a lag to the detection after, so the time that it needs to actually detect and then also send the command. But 3 works really great for me. And what we can do now is create a command buffer. And this command buffer is going to be initialized with an array of these remote commands that we just created. And then we're also going to have a current command, which is the most recent command that we received, and I'm going to set this. It's also a remote command, and I'm going to set this to none as an initial value. And to actually make this really simple and to react accordingly to the changes, we're making this a computed property and listening for or observe the did set event right here. So every time current command changes, we can actually send a command. But as I said, we do not want to immediately send that command. We want to create this buffer. Therefore, we're using our command buffer and we append the current command. And then we want to check every time we reach our buffer size. So we check our command buffer and its count. If it is equal to the buffer size, we want to see if our buffer really is just filled with 1 single command. This could be none, this could be fist, this could be open. So we're checking this by actually having a look at the command buffer, and we're filtering all the elements, and we check if each element that is currently inside of our buffer is equal to the current command, the most recent command. So only if we count that, so that we know that we are equal to the buffer size. So only if the number of elements that are equal to the current command are 3 in our case, we really want to send our command. So just adding an if block around that. And in that case, we actually want to send our command and show also a little bit of UI change. And after this process, what we do is just use our command buffer and remove all of the elements. And since we're just dealing with very small buffer, we haven't to worry about time complexity here. So we are going to now create a function that is going to deal with sending a command. Maybe let's call it show and send command. And as a parameter, we are going to pass along the current command. And then we also have to add this function. Let's do that right at the bottom of our file. So right here, I'm going to create show and send command. And we have our one parameter, which is the remote command. And what we do here is, first of all, check which command we're actually dealing with. So if our command is equal to open, then what I'd like to do is, of course, play my video. So self player view dot player and play. And also I'd like to update my UI. So I'm using my hand image view and the image, and I'm initializing that with an image. And now the cool thing is that I can just use named and passing along my command and its raw value because I've stored that as a string. The other case, else if command is equal to fist, what I'd like to do is use the player view, the player, and pause my video. And my hand image view is going to be updated to the other image of the fist, but just passing along the raw value here again. So if you'd like to display something else for the none event, you could do that right here. But what we are going to do here, since we're affecting the UI, I need to place that inside a dispatch block. So dispatch queue and main async, and we're going to perform all of that on the main thread. And with that done, all that is left is actually changing our current command every time we get our classification results in handle classification. So we're switching through the classifications, and its first element that we receive in this array, you remember we have this classifications array that came from the observations. We did convert that to VN classification observations, checked the confidence of each element, and then just took the identifier, which could be, for example, none. In that case, the current command is none. We have the case open, which means that the current command would be open. And we have the case fist. So the current command would be fist, and default, let's say the current command would be none. Which means that every time we have a classification result, we're checking what kind of result that is, and then we change the current command. Since we're observing current command, every time we change that, we're also actually showing and sending commands if our condition for a valid command or for a valid duration of a gesture is found. So with that done, and now running this on my iPhone, I can actually stop it with my fist. I can play it with my hand, my open hand. Stop, play, and stop, and play. So as you can see, this works quite nicely. And this concludes our fun little project from actually building our own hand classifier from tons of images and using CreateML to having a look at how to actually display video footage in a UI view using AVFoundation, to using Airplay, to actually using our hand to control a video. I hope you like that. Be sure to subscribe to not miss any future tutorials such as these. I wish you a fun WWDC 19 keynote day tomorrow, and I'll see you in the next one.